Hello and welcome to today's lecture on medium access control techniques. Today is the second lecture on this topic. In the first lecture, we have discussed about contention based protocols, which are essentially random in nature, and we have seen that there are collisions, and because of collisions it is necessary to do retransmissions after random amount of time. And as you know, whenever collision occurs, it leads to wastage of bandwidth, and whenever the traffic load increases, there are many collisions leading to loss of throughput, and ultimately it may lead to thrashing situation. We have seen that. And in this lecture we shall consider about collision free protocols, where collision is completely avoided. Here is the outline of today's lecture. I shall explain what do you mean by collision free protocols. Then we shall discuss one important protocol which is primarily used in wireless communication, that is carrier sense multiple access with collision avoidance. Here collision is avoided. Then there are two more techniques which are essentially controlled access techniques, also known as round robin medium access control techniques, known as polling and token passing. Then we shall discuss reservation based medium access control techniques, and they can be broadly divided into two types, distributed and centralized. We shall discuss both types, several examples of both the types. And on completion of this lecture, the students will be able to understand the need for collision free medium access control techniques. They will be able to explain the operation of CSMA protocol that we shall discuss, and they will be able to explain round robin based medium access control techniques such as polling and token passing. And finally, they will be able to explain reservation based protocol techniques which are primarily used in satellite network, which are distributed as well as centralized protocols are there. We shall discuss both of them. They will be able to understand and explain both of the techniques. Here is the overview of the total picture. In the last class we have discussed the random access protocols like Aloha, CSMA, CSMA CD, pure Aloha and slotted Aloha. As we know, these are all contention based, where collision is allowed to take place, particularly when the traffic increases, collision occurs. In this lecture we shall consider CSMA CA, then round robin and reservation based protocol, as I have mentioned. Question arises, why do you need CSMA CA or collision carrier sense multiple access with collision avoidance? Why do you need it? The need has arisen because of the proliferation of portable computers, and which requires radio signals for communications. As we know, the wireless those portable computers cannot be, although they can be connected, but to maintain portability they should communicate with using radio signals. And as you know, all radio transmitters have some fixed range. So, as the range increases, the intensity decreases at the rate of d square, as you know that. And when a receiver is within the range of two active transmitters, the resulting signal will be generally garbled. That means, whenever a particular station is in between two transmitters, it will receive signal from both the transmitters and the signal will get garbled and it will be useless. So, that is why collision cannot be that type of situation should not be allowed to happen. And as you know that CSMA CD is unsuitable in such environment. The reason for that is in wireless environment it is very difficult to detect collision because of that attenuation, fading, and also it is in the radio level it is difficult to detect the collision. And that is why that CSMA CD protocol that we have discussed cannot be used here. And moreover, there are two problems because of the special situation that I have mentioned. These are known as hidden station and exposed station problems, which we shall discuss in detail. And we have to develop techniques which are suitable for this kind of environment. Let us first discuss the hidden station problem. And here as you can see, this station A is transmitting some signal, and this circle shows the range over which the signal is received properly, and beyond that the signal is very weak, and particularly the signal to noise ratio will be very small and signal cannot be detected properly. That is why this is the range of this transmitter A, station A. On the other hand, the C is also transmitting simultaneously, and this range is mentioned shown with the help of the other circle, this circle. So, two circles are showing the range of two transmitters which are transmitting simultaneously. As you can see, B is in between. As a consequence, B will receive signal both from A and C. As a result, the signal here what will be received by B will be garbled, and it will not be able to find out, I mean will not be able to get the packet or message which is sent either by A or by C. But unfortunately, this signal the transmission sent by A will not reach C, and also the transmission sent by C will not reach A because of longer distances. As a result, they will not know that some kind of collision has taken place and B has not been able to get the signal. So, that means in such a case both the signals will reach B and collision will occur, but A and C will not be able to detect the collision. So, A and C will not know. This is the hidden station problem. So, this is hidden between two stations. The other problem is known as exposed station problem. Here as you can see, station B wants to send to A, wants to send a frame to A, and which is also listened by C. That means both C and A are within the range of B. As a result, whenever B transmits, both A and C will listen to it, and as a consequence C will decide that C is not able to transmit to D, because it will assume that the signal sent by B will also reach D and collision will occur, and this is known as exposed station problem. Although in practice, when B is transmitting to A, C can simultaneously transmit to D, it is possible, but if we use normal technique that CSMA or CSMA CD, this cannot be done. And so what I intend to say, in this situation B can transmit to A and C can transmit to D simultaneously, but that our protocol will not allow it unless we develop a suitable protocol. That can be avoided by using a special protocol known as carrier sense multiple access with collision avoidance. Here collision is completely avoided by using suitable protocol. Let us see how it is done. Here sender sends a short frame called request to send RTS, which is about 20 bytes, to the destination. The request to send also contains the length of the data frame. That means that request to send packet will contain the information about the length of the data packet. This destination station will respond to it with a short frame which is of 14 bytes, which is known as cleared to send frame. And after receiving the cleared to send, the sender starts sending the data frame. Here all the stations which will receive this cleared to send will defer transmission. So, if collision occurs, of course, there is a possibility that there will be multiple cleared to send frames will be present in a particular situation, and in such cases there is a possibility that cleared to send frame will suffer collision. So, in such a case there will be some backup technique has to be used, so that that cleared to send message or packet is received by the sender. Let us see how exactly it happens. So, here A sends a frame request to send, which is of 20 bytes, and when it reaches B, which sends a 14 byte cleared to send frame. Now, after hearing this cleared to send, as you can see here, A is sending request to send, B will send the cleared to send, and that particular signal will be listened by C as well as by A. As a result, C will defer transmission, and of course, if both of them request simultaneously, there will be some kind of collision, but that cleared to send will be sent either to A or to C. One of them will be sent and the other one will defer transmission, and as a consequence, as one of them will defer transmission, this exposed station problem will be overcome. And after receiving this cleared to send, data will be transmitted by either A or by C, depending on who receives the cleared to send, and after the data is sent, the acknowledgement will come from the receiver. Now, the exposed station problem also will be overcome here, that this problem, that exposed station problem, as I mentioned, will be also overcome here. For example, whenever B sends a packet to A, then A will send a request to send packet will go from B to A, and A will send a cleared to send. That means, let us start again once again. So, here it is B is sending to A request to send, and A will respond with a cleared to send. Now, this signal whenever A sends to B, obviously it will not be listened by D. So, if C request sends a cleared to send to D, that cleared to send will not be listened either by A or by B. As a consequence, if C sends a request to send to D, and that cleared to send will be received only by C. As a consequence, the B will be able to send to A and C will be able to send to D simultaneously. So, we see that parallel data transmission between D and C and D to C, C to D and B to A is possible by using this protocol. So, this is known as 4-way handshaking protocol, and by using this 4-way handshaking protocol, that means request to send, cleared to send, data and then acknowledgement. You can see 4-way handshaking protocol. This is known as carrier sense multiple access with collision avoidance. So, you see the data packet does not suffer collision in any situation. So, we have seen how collision is avoided in wireless communication, particularly this protocol is used in wireless LAN, as we shall discuss in detail later on. Now, we shall go back to the round robin techniques, and this the one important approach used in round robin technique is polling. Polling is a very common situation used in many practical situations. This particular technique is used in many practical situations. For example, in classroom we do the roll call by using polling, or we ask questions to the students by using polling. The teacher one by one calls the roll number of the students, or ask a particular students one by one and ask the answer. So, similar thing is done here. Here you have got stations take turn in accessing the medium. That means, in such a case, one station is termed as primary. It can be considered as teacher or the chairman in practical applications, and other stations are called secondary. and there are two distinct modes. So, whenever this primary wants to send data to one of the secondaries, then it can be select mode. First, the primary has to select a particular secondary by sending its address, and whenever the secondary response sends an acknowledgement, then the data transfer is performed. On the other hand, in the polling case, data is coming from the secondary to the primary. In such a case, primary will send a polling signal to one of the secondaries, secondary will send an acknowledgement, and then the data transfer will take place. Let us see how exactly it happens. First, let us consider the polling mode. So, in this case, the polling signal goes to all the secondaries, and one of the secondaries will send an. So, if it has got no data to which the address was given, then a no acknowledgement signal will come, and the another polling signal will be sent by the primary, and if the polled secondary has some data to send, it will send and it will send the data, and then the primary will send an acknowledgement to the secondary. So, this is how in the poll mode data is one by one, the polling is done by the primary one by one, and it gets data from the secondaries in round robin manner. And next one is the select mode, in which data goes from primary to the secondary. So, selection signal goes with the address, and the that particular station, one of the secondary stations will respond with an acknowledgement packet, and then data transfer is data is sent by the primary to the secondary, and then the secondary will send an acknowledgement. So, this is how the polling is performed whenever a number of stations are connected to a bus which is shared by all the stations. So, polling is being performed here. Now, the polling can be done in wireless communication also. There can be a central controller which may use a frequency band to send outbound signal. So, you can see this is the outbound signal. This controller is sending outbound signals, and this is some kind of broadcasting which is received by all the other stations, and other stations share a different frequency to send the inbound messages. So, others will send some signals which are essentially shared by all the stations. Now, this kind of technique where the bandwidth is divided into two parts, one is outbound, another is inbound. This is your outbound, this is your inbound, and this technique is called frequency division duplex approach or FDD approach. So, in such a case, that centralized controller will send message to all the other stations by using this outbound frequency band, and all other stations will send message by using that inbound messages, and then the polling is performed one after the other. The stations will be asked to send data, because since it is broadcasting, since this is a broadcasting situation, all the stations will know, and only the polled secondary, although it is shared, will be sending the data to the central controller. So, all the data transfer will take place through the central controller. Polling can be done without using the central controller also. It is here is the situation where you have got a number of stations, as you can see, and there is no central controller. Here all station receive signals from all other stations. So, here if this station transmits, all the other stations will be able to receive it, because it is some kind of broadcasting. Whenever one of them transmits, all the other stations will receive it, and the stations will develop a polling order list using some protocol. The details of the protocol is not mentioned here, but in this distributed fashion, all the stations will use some kind of protocol by which the one station will send data to the others. Of course, based on the address, only the destination station will receive the data. So, in this way, one after the other, each station will transmit, although it will be broadcasting, but the packet meant for the destination station will accept the data, others will ignore it. So, this is how polling can be done without using the centralized controller. So, it can be done in a distributed manner. Now, here it is shown in detail how the polling messages are performed, sent one by one with the help of a central controller. So, here this is the primary station. So, these are all the secondary stations. So, you see this is the time. First, this one is mentioned that this is the walk time required for propagation of message from the central controller to reach the station 1. This is the station 1. So, the station 1 will receive the message and then it will respond. So, it will take some time. This time is known as walk time. So, time required for the propagation of message and the station begins transmission. So, from this to this time is known as the walk time for polling station 1. Then the data transmission from station 1 take place. Then it will poll station 2 in the same manner. It will have some, it will require some time, walk time for polling 2. Then the station 2 will transmit data. In this way, M station will transmit one after the other, and again station 1 will get its turn. So, you can see all the stations will get their turn for sending message to the central controller, and of course, central controller can also send data in this manner. And total walk time can be considered as the overhead in the polling process. That means, this time, this is essentially the overhead for transmission, and you can calculate the throughput based on the total walk time required and the total time spent for sending the messages. And here the overhead can be made very small, because this time propagation time is usually small whenever the stations are located whenever stations are located nearby, not satellite communication or of that kind. So, this walk time can be quite small and throughput can be quite high. Of course, there will be some transmission time involved, that means the propagation time and transmission time of the packet coming from the central controller to the station, and also packet transmission time of the stations going to the central controller, acknowledgement or no acknowledgement packets. So, this time is known as walk time, and total walk time is the total overhead. So, in this way you can calculate the total overhead and find out the throughput. Now, we shall discuss the second approach for second approach used for round robin technique, that is known as token passing. So, in a token passing approach, all stations are logically connected in the form of a ring. You note down this particular term logically. So, here we have shown the stations are not only logically, but physically connected in the form of a ring. So, here for example, this particular station is connected to its neighbor D and B, D is connected to A and C is connected to D and B. So, in this way all are connected in the form of a ring. So, this particular interface is connected to its neighbor by using point to point links. As I mentioned, this point to point link can be either twisted pair or it can be coaxial cable. So, either usually coaxial cable is not used, it can be either twisted pair, or if the distance is very long it can be optical fiber. So, either twisted pair or optical fiber is used for point to point link between the pair of stations. Now, this ring is essentially the shared medium used for communication, and that access to the medium, control of the access to the medium is performed using a token. What is a token? A token is essentially a special bit sequence, or it can be considered as a small packet. This packet is circulates around the ring, and whoever is the owner or whoever captures a token gets the right to transmit. So, token is circulated in a round robin manner, holder of the token has the right to transmit. So, here somehow a token is introduced, say suppose A is holding the token. So, it will send the data transmission will take place and it will come back to A, then it will release the token, it will go to B. sorry, it goes in this direction. So, it will go to B, and so whenever it receives the B captures the token, it will then send the data, it will go around the ring, it will come back to it, it will take out that data packet, data frame, and then introduce the token, it will go to C. In this way, it will, that token circulates around the ring, and whenever a particular station has no data to send, it simply passes on the free token to the next stations. This is how it goes on. As we will see, this is explained with the help of this flow chart. So, all stations wait for the token, and whenever token is received by its network interface, we have seen there is some kind of network interface, and that network interface, so this is a station and this is the network interface. So, token whenever it passes by through this network interface, then it is captured, and if it has got data to send, it checks whether it has got data to send. If the answer is yes, it sends the frame, and now it is now possible to send multiple frames, not one. If the time allocated is long, multiple frames can be sent before releasing the token. So, it keeps on sending data until the time is over, and after the time is over, it releases the token and it stops. So, this is what goes on in a particular station. So, in this way, each station waits for the time for the token, captures it, sends the data, and after all the data is transmitted or the time is over, it comes out of it, it releases the token, and then it goes to the next stations. So, this is how the data communication take place in a round robin manner in token passing using token passing protocol. Let us see the performance of token passing protocol. The performance can be explained by using two parameters, one is throughput, another is delay. So, this throughput, it is a measure of the successful traffic, that means how many packets have been transmitted. As you know, it gives you the measure about how many packets has been transmitted per unit time or per second, how many frames have been transmitted, that is your throughput. And delay, it is a measure of the time between when a packet is ready and when it is delivered. As we have seen in the previous diagram, it waits for a token. So, what is the waiting time? That waiting time can be very long if there are a large number of nodes stations in the ring, and on the other hand, if the number of stations in the ring is small, then the waiting time can be small. So, this is the measure of the delay. It is a measure of the time between when a packet is ready and when it is delivered. So, let us see, it depends on what parameters. A station starts sending a packet at t is equal to 0, t0, and completes transmission at t is equal to t0 plus 1 and receives the tail at t0 plus 1 plus a. So, you can see at t0 it completes transmission, and then this a is the ratio of the propagation time by transmission time, and in this case transmission time has been considered to be 1. So, it is normalized with respect to the transmission time, and a is the ratio of the propagation time by the transmission time. So, this station will receive the tail at t0 plus 1 plus a. Now, what is the average time required to send a token to the next station? It is a by n. As I mentioned, this is dependent on n propagation time as well as n. So, for larger value of n, that means that it will depend on the ratio of a and n, and for whenever the number of when the number of stations is large, there can be a long delay. And throughput is expressed as s is equal to 1 by 1 plus a by n whenever a is less than 1. That whenever there are two situations. So, a has started sending the frame and it goes around the ring, around the ring. So, if the bit time, that means the total propagation time is smaller than the packet transmission time, before it completes transmission, the tail that front will be reaching the transmitter. And another situation is whenever the transmission time is small and propagation time is large, in that case the station will finish the transmission of a frame, and only after transmission is completed, it will the front of the frame that is it has sent will reach the station. So, this is being expressed by this parameter, that means A is less than 1 means that A is less than 1 means that the propagation time is small compared to the transmission time. So, propagation time is lesser than transmission time. In that case, this is the expression for throughput. On the other hand, whenever the propagation time is very large, in such a case S is equal to 1 by A into 1 plus 1 by n for A is greater than 1. This is the situation when the either the transmitter is sending very fast or the loop ring is very long. So, in such a case there is a possibility to have multiple token and multiple frame. Normally, in this particular situation, it is not possible to have transmission of multiple frame or multiple token, but in this situation it is possible to have multiple token and multiple frame. We shall discuss about this technique in more details whenever we consider the standard lengths. We shall see that in the normal token ring based on coaxial cable, the length of the ring is small and speed is small. So, when in such a situation, that propagation time is relatively smaller compared to the transmission time. On the other hand, when the ring is when we are transmitting at a very high speed, then the transmission time is small and relatively propagation time is longer. In such a case, it is possible to have multiple token in a single ring, and parallelly multiple frames can be sent. We shall discuss about it in more details later on when we shall consider the LAN network based on token passing. Now, it is now necessary to compare the CSMA CD, which is one of the popular protocol used in local area networks, and also with respect to this token ring, token passing. So, if we compare these two, we find that the token ring is least sensitive to workload and propagation effects. That means, so whenever as you are increasing the load, we have seen that CSMA CD is affected heavily. We have seen that curve initially that throughput increases, and after reaching a peak it starts dipping and it falls down. But in case of token passing, you will see that it will increase linearly. That means, there is no degradation in throughput as the load increases. So, it is least sensitive to workload and propagation effects. However, whenever the number of nodes is very large, the delay will be long in case of token ring. That means, the CSMA CD has the shortest delay under light load conditions. We have seen that in case of CSMA CD, if the load is light, a particular station transmits a frame, and if it does not suffer collision, delay is very small. On the other hand, in case of token ring, a particular station has to wait for a long time to get the token, and as a consequence there is a long delay in token ring. On the other hand, the delay is very small in CSMA CD. However, if there is heavy load, then it will suffer collision, and as a result delay can be long. So, CSMA CD has shortest delay, but is most sensitive to variations of load, particularly when the load is heavy. So, these are the two performance comparison between CSMA CD and token ring protocol or token passing protocol. And based on another important observation based on the protocol, you see in case of CSMACD we have seen that there can be multiple collisions, and whenever an unfortunate frame suffers 15 collisions, it is discarded. So, in case of CSMACD, which is based on stochastic or probabilistic technique, there is a possibility that an unfortunate frame is never transmitted. In other words, the delivery of a packet to the destination is not guaranteed. On the other hand, in case of token ring, token passing protocol, the delivery is guaranteed. The reason is that even when the load is very large, the delay can be long, but the packet will be ultimately delivered. That is why that CSMACD is not suitable for real time traffic. In real time traffic, we cannot afford to discard a packet or frame. So, in real time applications, the CSMACD protocol is not very good. It is good only in burst situation. In burst situation when the traffic is small. On the other hand, the token passing protocol is very suitable when you have got stream traffic. So, whenever you have got streams of data coming at a regular interval from all stations, it is not burst in nature, then the token passing protocol works better, or round robin technique works better. So, these are the relative comparison between the contention based protocols and the round robin protocols. Now, we shall come to the reservation protocol, and which is essentially based on the satellite networks. Let us look at the unique features of satellite networks. As we know, there is long round trip propagation delay, which is about 1/4 of a second. So, here you have got a satellite, and here are the ground stations. As we know, the satellite is located at about 36,000 kilometer away above the ground, and the round trip delay is about 1/4 second. So, round trip delay is 1/4 of a second. So, this is the time, this is a relatively very long time. 1/4 of a second in today's context is quite long time, and this has to be taken into consideration when we develop a protocol. And after the round trip delay, a station comes to know whether a packet transmission was successful or it suffered collision. That means, if a ground station, say transmitter, sends a packet, as we know, the satellite will receive it and then send it using the downlink frequency, and it will do the broadcast. So, if multiple stations sends a packet which is essentially shared, then there will be some kind of collision, or the signal will be garbled, and the transmitter will come to know about it only after 1/4 of a second, not before that. And as a consequence, CSMACD based protocol are unsuitable for in such a situation. The reason for that is, what a particular station, whenever a collision is detected by a station, it knows actually it has happened 1/4 of a second earlier, not now, and as a consequence we can say that the value of A, that is the ratio of the propagation of time by the transmission time, is very large. And as we know, whenever A is large, then the throughput or the efficiency of the CSMA based protocol is very poor, and that is why the CSMA-CD or CSMA based protocols cannot be used in situations where the propagation delay is very long, particularly in satellite communication. In satellite communication, as you have seen, that propagation time is quite large, and as a consequence the schemes based on collision detection cannot be used. Let us see whether we can use polling. You see, if we use polling, then that polling signal has to go from the central controller to all the stations, and that sending the frame and getting the acknowledgement from the that the stations will take about 2 round trip delay, that means half of a second, which is very large. So, that means just for polling, which is part of that walk time that I have mentioned, that time will be quite large, and as a consequence this polling will be very inefficient. Similarly, the token passing also will not be suitable for the satellite networks, because to send the token, say station will take at least 1/4 of a second to send a token to the next station, and as a consequence neither CSMA based protocol, contention based protocol, nor the round robin type protocols can be used in satellite networks. So, in such a situation a new technique have evolved, which is known as reservation based protocols, and these reservation based protocols can be broadly divided into 2 types. The first one are distributed, and second one is second category is centralized. We shall consider several protocols based on distributed as well as centralized techniques. First one is R aloha, which is essentially means reservation aloha. Here there are some basic assumptions. The basic assumptions are the time is divided into a number of slots. That means the frames are the time is divided in terms of slots, and this is synchronized. Secondly, there is another assumption, the round trip delay, that means the this is the frame time, that propagation time, this frame transmission time should be at least greater than the propagation time. In other words, by the time one frame is transmitted, this time should be longer than the propagation time. These are the 2 assumptions which is made, and in reservation aloha frame length must be at least as long as the bit length. Bit length is essentially the propagation time. That means that this time should be more than 1/4 of a time, 1/4 of a second, that is the propagation time. This is known as the bit length. So, bit length should be more than the frame length. Now, here a station contends for a slot in the next frame. So, here what is being done, the situation is the total number of frames, here k is essentially the number of k is greater than the number of slots. That means, the number of slots is larger than the number of slots is smaller than the number of stations. So, number of k is the number of stations is larger than the number of slots, and it works in this manner. Let us in this manner say whenever in a particular slot, that means a particular frame is transmitted and each station is receiving whether a particular slot is empty or free. So, whenever a station frame is found to be empty, then a station sends frame to transmits in that particular slot to book it. However, it may suffer collision or it may not suffer collision. Let us assume that there are 8 stations and 4 slots for simplicity, and let us assume initially station 1 is transmitting here, this is unused, and this station 2 is transmitting here, and this is also unused. Now, this will be received by all the stations. Now, station 3 wants to decide in this slot. So, in the next frame, station 1 sends here, station 3 sends here, 2 sends here, and let us assume 4 and 5 decides to send in this slot. So, there will be some collision here. So, we can see here collision will occur in this frame. Now, the third frame can happen in this way, 1 will send transmission here and 3 may continue, and suppose 2 has finished transmission. So, it will remain unutilized and in this frame again will remain unutilized because of collision. So, we find that there can be three situations. A particular slot may be used in this case, or a particular slot may be unused, remains unoccupied, or there may be collision. Now, there are, if a particular stations keeps on sending continuously, then it may appear like behaves like a TDMA, that means time division multiple access, and when this station sends long streams of data. This is the situation for this slot. As you can see, this slot, in this slot the station is continuously sending. On the other hand, if the traffic is bursty and the number of packets sent by different station is small, in that case it will appear to be slotted aloha. As you can see, this particular slot, say 2, then unutilized, and then 1. So, in this way alternately different stations can transmit in different slots. So, it may appear like a slotted aloha. This is the reservation aloha protocol used, and here you can see the number of it has been assumed that the number of slots is smaller than the number of stations. Let us consider another situation. In binder scheme, the number of slots stations is smaller than the number of slots. So, in this case the number of station is smaller. Earlier the number of stations were larger, than the number of slots. So, in this case, since the number of stations is smaller than the number of slots, you can see each station is allocated a particular slot. That means, here some kind of implicit reservation is there. Implicit reservation for slots are provided because the number of stations is smaller, and extra slots are available in which transmission can be reserved by using that slotted aloha, as I have already mentioned. So, let us assume there are only 4 stations and there are 6 slots. So, you have got 6 slots and 4 stations. So, this is reserved for 1, this is reserved for 2, this is reserved for 3 and 4, and these 2 are unreserved, these 2 are free. And in this initially, say suppose the first, in the first frame a particular station 1 sends here, 2 sends here. If 3 has no data, it remains unused. So, it is unused, and say 4 sends here. Now, if station 4 has got more data to send, it will it may send here by sending data using the slotted aloha, and say suppose station 2 also can send here. Now, in the next frame what can happen, since this is unutilized, a particular station may capture it by sending frame in it. Say 1 can send here, 2 can send here, say 3 can, it is, although it is allocated to 3, since 3 has no data, it was unutilized. So, another station say may 4 can block it and send data here. So, in this way the transmission can go on. So, here you see it is superior to reservation aloha for stream dominated traffic. However, whenever the nature of traffic is bursty, then of course, it is not very efficient. So, here we see we are doing some kind of implicit reservation. It is a mixture of implicit reservation, and it is a combination of implicit and explicit reservation. So, for these stations the reservation is implicit, and for these excess slots the reservation is explicit. Explicitly it has to be done by using slotted aloha. So, this is binder scheme, and as I mentioned, it will perform better whenever the number of stations is when the traffic is stream dominated. There is another interesting scheme proposed by Roberts, and here explicit reservation is necessary by sending request in a mini slot which acts as a common queue in each frame. So, here we see this is a frame. Now, this frame is divided into a number of slots, and not only it is divided into a number of slot, one of the slot is divided into a number of mini slots. So, it is divided into a number of mini slots. Now, in these mini slots the stations can send data and reserve the transmission. Suppose the number of mini slots is equal to the number of senders. So, if it sends here, then this is blocked, if it sends here, then this is blocked. In this way blocking can be done, that means successful transmission in mini slots. In a mini slot allows reservation, that means it is not explicitly for a particular station. If a particular station is successful in transmission in a particular mini slot, that particular frame, suppose in mini slot 1 a particular station has transmitted, then it books it for slot number 1, and if it say this is the mini slot and here are the other slots, let us assume. So, if station is successful in sending in mini slot 1, this is reserved for that station. If another station is successful in sending in this mini slot, it is reserved for this station. In this way, by sending some data, sending a reservation frames in the mini slots, the reservation can be done explicitly for the subsequent frames. Now, when for lengthy stream there can be considerable delay. Why there can be considerable delay? Because we find that in this case each station has to explicitly book for sending a frame, and each time it has to be done. So, for each frame explicit booking is necessary. Now, if a particular message is divided into a large number of packets, so it can suffer long delay, because to send this packet explicit reservation will be necessary, to send next packet another explicit reservation will be necessary. In this way for each of these packets there will be need for explicit reservation, and which will lead to considerable delay. So, this is the disadvantage of this Roberts scheme. Now, these are the distributed schemes which we have discussed in detail, where we have seen the stations are doing their reservations by sending packets with by using slotted aloha. Now, the distributed schemes suffer from the disadvantage of higher processing burden of each stations. That means, each station must have the processing capability, they should be able to send data, reservation packets. As a result, the high processing burden is necessary. On the other hand, distributed schemes are vulnerable to loss of synchronization. So, that is why centralized scheme can be used, and two centralized schemes will be discussed in this we shall discuss. One is known as fixed priority oriented demand assignment, and second one is packet demand access multiple access. So, this is centralized FPOMA priority oriented demand assignment. It is an extension of Roberts scheme. It has got 6 stations, acts as a controller. You can see there are 6 one of the 6 stations acts as a controller. Here it is a centralized scheme. So, there should be a controller. The stations can send their request in mini slots. So, here there are mini slots. So, we have assumed that there are 6 stations. So, these are the 6 mini slots in which request can be sent, and the priority of that packet, whether it is a normal or it is interested in sending normal packet, or there is a bulk data, that also has to be specified. And the controller maintains a queue of requests and allocates 6 variable length slots. As you can see here, the slots are not fixed. So, based on these requests, the controller will allocate the the frame slots of variable size, and all the 6 stations will be able to send variable size frames in these slots. This is your centralized FPOMA, and this PDA-MA has got 4 different types of slots. There is a leader control slot, a guard slot, a reservation mini slot, and data slots. The leader control slot is used by the master. station to communicate acknowledgement. So, this is used for to communicate acknowledgement to all the other stations, and guard slot help other stations to hear the leader control slot and prepare for the reservation, and also it can be used for ranging. The reservation mini slots for reservation are used for reservations. Here the other stations can send their requests using slotted aloha, and the data subframe is used for variable length data. So, this subframe is used for sending variable length data by other stations. So, this is a centralized scheme. So, we have discussed different types of reservation based protocol. Here are the review questions. First question is, what are the advantage of collision free protocols over random access protocols? How does CSMA differs from CSMA CA? Third question is, compare and contrast CSMA CD and token passing protocols. Fourth question was, why CSMA CD or token passing MAC protocols cannot be used in satellite communication. Fifth question is, compare the distributed and centralized reservation protocols. Here is the answer to question number 1 of lecture number 25. Question was, in what environment it is necessary to have MAC for data communication? Answer is, in broadcast networks a single transmission media is shared by all the users and information is broadcast by an user into the medium. In such cases a protocol is necessary to orchestrate the transmission from the users. The protocol is known as medium access control. Second question was, how performance is improved in slotted aloha compared to pure aloha? Answer is, in slotted aloha packets are transmitted in fixed time slot as you have seen. This reduces the vulnerable period from TF to 2TF of pure aloha. This in turn improves the performance or throughput from 18.4 to 36.8. Third question was, distinguish between persistent and non-persistent CSMA scheme. Answer is, in case of non-persistent CSMA, medium is resensed after a random amount of time when the medium is found to be idle. Only on the other hand, medium is continuously sensed in persistent schemes. Fourth question was, how does the efficiency of CSMA based schemes depend on A? Answer is, the parameter A decides the vulnerable period in case of CSMA as well as in CSMA schemes. The longer the propagation delay, the longer is the value of A, and longer is the vulnerable period. Longer the vulnerable period, lesser is the efficiency, as you have seen. Last question was, how performance is improved in CSMA CD over CSMA technique? Answer is, in case of CSMA technique, packets are transmitted till the end even when it suffers a collision. As collision can be detected within a fraction of packet transmission time, medium is monitored during packet transmission. So, in CSMA CD technique, packet transmissions are stopped as soon as collision is detected by the station. This results in more efficient utilization of the bandwidth of the medium. So, this concludes today's lecture. So, in the next lecture we shall discuss about the channelization technique of medium access control. Thank you.